Welcome everyone. In today's class, I will give a demo of one set solver, Crypto Mini Set. The Crypto Mini Set is an open source set solver which is available in this link. So you can download and install in your machine. And as any set solver does, you can give any Boolean formula in conjunctive normal form or CNF, and then this tool will take this and try to see whether it is satisfiable or unsatisfiable. So if it is satisfiable, it will say yes, and it will give an assignment to the input variables, right. Say for this input the formula is true, and if there is no such input exist, it will return unset. So Crypto Mini Set also does the same thing. So first thing is installation. So this support, the current version support this, so it should be your C++ should be at least 7 and above. This is Crypto Mini Set 5 and this is Python 3 also we have used to generate the formulas, right. So it is there in GitHub, so you can actually clone and you can do this. So you can actually use this kind of command, apt-get install Crypto Mini Set, and if your all dependent things are okay, it will install, right. And then whether it has been installed correctly or not, you can check by this the version, right. It will also say that this is the Crypto Mini Set version 5.8 and all, right. So the detailed instruction is given in the corresponding GitHub page. If you are using Linux, Ubuntu or Debian, then you should use this kind of command line. If you are using Mac OS, the command is given, and for Windows also the proper command is given in the website, right. So installation will be easy, and also if you want to clone and do it, it is possible, right. Or you can download the binary and you use it or install it, right. So after the installation, as I mentioned, you have to give your Boolean formula, and the formula usually given as a Dimax format, right, that I have already discussed in previous classes. So this is let us say one of the sample input which we can give it to this Crypto Mini Set, or rather any set solver, where I have to specify what this is a CNF formula. There are 3 variables and 3 clauses, right. So this 3 mention that, right. So you can think about that I have variable A, B and C, and this is clause 1, this is clause 2, this is clause 3. So first clause, every clause end by 0, right. So always the last digit is 0. What the first clause says is basically 1 literal, and it is positive literal. So effectively the first clause 1 is basically A, if I assume my variables was ABC. The second clause says that it is a second variable and its negation, right. So it is not B. Third clause says that it is not A or B or C. So these are the 3 clauses, right. So this is very obvious formula, because you have to make each clause true. So this should be true, this should be false, right, B should be false, right. So A is true, B is false, so that this is C1 is true, C2 is true, and since this is already so this is false, this is true, so C should be true, right, to make this formula. So this is one of the assignment under which this particular clause will be true, right. So given, but your formula may not be in this format, right. So this Dimax format, you need to convert it always, right. You can have any examples, any Boolean formula. So you have to first convert into CNF using Seitin transformation, and then you convert them into Dimax format, right. It is very easy to do. And then if you run this Crypto Mini Set command with this file, let us say this file input is stored in this file, it will say satisfiable because I already found it, and solution it gives is basically this means A equal to true, this means B equal to false, this means C equal to true, right. This is what the solution I identified, right. So this is how the use is very simple. So any set solver you can just install, and if you can store your problem in a CNF format, in this Dimax format, you just give this file, it will give you the output, right. It is pretty easy to use, there is not difficulty, right, and installation is also really simple. So one challenge here may be that how to convert this into Dimax, right, or the problem that you are handling, what is the actual problem, right. In the previous class, probably you have remembered that I use the logic locking problem and I develop an attack where I use SAT solver at the background, right. So, what I will do today, I will in this demo classes, I will take the same example that I have taken in the previous class and I will show how if I run it through crypto mini SAT, what is things is going to happen, right. So, this is what I am going to do. Just to recap in 2 minutes, what is logic locking is you have original circuit which if you give it to somebody they can use it unauthorized way. So, what you do, you basically insert some key gates and lock it with keys, right. So, that this circuit, the lock circuit, even if you go to the users, they cannot use it without the correct value of the keys. And the logic is that whenever you locked a circuit, this circuit is equivalent to the original circuit for only one value of the keys. For example, the example I have taken for this case, this is the value of the keys under which these two circuits are equivalent. For any other key values, the output may or may not match with the output, right. So, since there are 3 inputs here, there are 8 possible inputs, input values for this circuit. If you give some other key value, let us say 0, 0, 0, if you give this 0, 0, 0, this circuit for 8 cases of input, maybe in 5 cases give correct output, in 3 cases output may be wrong. I am just giving an example. So, your output will not be exactly same as the original circuit. So, people cannot use it, right. So, our objective is effectively to if somebody has given this lock circuit and a oracle where I can give an input, I can check what is the correct output, how can I get the key values, right. That was the attack problem that I am doing, right. So, this is what I have said, I have the locked circuit and a oracle which is basically a functional IP, which is a black box, which can be the IP that you can purchase from the market, where you give the input, you will get the output, right. So, your objective is to identify the correct value of the key used in this circuit, and we will use SAT solver, specifically the crypto mini SAT solver in this demo. So, whenever you have given a circuit, all the benchmark circuit usually convert into a bench format, right. So, this is very standard format called bench file. So, any circuit benchmark circuit, you will get this in format and it is very easy. So, here you say this is input A, input B, input C, input K1 and many other things are there. I am just showing a part of this, not the entire thing, right. Okay, in this small circuit I think and your output is Y, right, and this is your AND gate, this one where input is A and B and output is N1, this wire is N1. For this AND gate, input is B and C, output is N2, right. This is what N2. For this XOR gate, your input is N2 and K1, this is N3, and then for this OR gate, you have N1 and N3 is the input and output is Y. So, this is a complete circuit with a small circuit. So, this is the things you will be given effectively, which represent your circuit. Okay. So, what you have to do, you have to first convert this into CNF. So, this is effectively you will get a expression for Y, right, which is expression of Y in terms of this, right. If you just rewrite this, you will get the expression, right. So, it is OR N1 or N3, right, and then N1 is basically A and B, right, or N3 is K1 XOR N2 and then A and B where N2 is basically B and C, or K1 XOR B and C, right. So, this is the expression corresponding to Y. So, this is the expression you have, which is you can get it from this bench file. This you have to convert into CNF using Seitin transformation, and then you have to convert into Dynamax. The Dynamax format I have shown you in the previous file, right, something like this. So, this you can write your program because this may not be there in your tool, right. So, we have written a small Python code for that. We have effectively shared this entire thing in a GitHub. I will show you the link at the end of the class. And then where if you give this circuit, it will create this corresponding circuit in bench format, right, using this command. So, the input is basically like a bench file like this, right, and then if you run this Python code, you will get this format. And this is not only doing this, if you remember the SAT attack, what it does is create a mitre circuit, right? In the circuit, how do I formulate this problem as a SAT problem, that I have discussed in the previous class, right? Just to recap what we have done effectively, I have given this circuit, a lock circuit, I create 2 copies, same circuit 2 copies, I connect the inputs as that is from both of them, create 2 copies of the keys, right? And then output also I created 2 copies, 1 and 2, and then at the end I just check whether they are same or not with a XOR gate. So, this entire thing I convert into CNF, right? This is my model, SAT model. So, this I have to convert into CNF and then I have to call SAT solver for this, okay. So, this is what it can be done with this Python file, right. So, what this exactly it will do, it will try to give you the some input values and 2 key values for which for this input output are different, right. That is what I want, that output should be different, and it will also give 2 value of the key, which is not so important for me. I am more bothered about the input for which we have 2 different key values for which output will be different, and that input is called DIP, distinguishing input pattern, right. So, once you get this DIP, what you will do, I will talk about that more, right. So, what initially did, I take this short circuit, I create this modified circuit, and this I convert into CNF format, okay. So, what are the total clauses for the example that I have? So, for this circuit you have 27 clauses, you can cross check, and similarly the copy circuit will also have 27 clauses, and this not equal to checking is basically XOR, which is basically these 2 clauses. So, effectively there will be 56 clauses in my Boolean formula for this circuit, the SAT formulation of DIP finding for this circuit, right. So, this I will give to the SAT solver, and you can just call this crypto mini SAT with this, right. So, I have already shown you how to run this crypto mini SAT. If you run this crypto mini SAT, what will happen? If you run like this, with now the file will be that file, you will get some satisfiable and the value of all this input variable AB, this 2 copies of the keys and the input, right. This will get. But in the SAT attack, what we usually do, we take this and then this input I give it to the oracle, I will get what the output, and from that output I rewrite this formula with this input output, so that I get a clause in terms of the keys, right. To give a concrete example, so let us say I just model this DIP formulation, this one I give it to SAT solver, I get a DIP, right, some value of this ABC. In my circuit there are inputs are ABC, right. So, the inputs are ABC. So, I will get some value of ABC, and then this ABC values, let us say I got this, right, A equal to 0, B equal to 1 and C equal to 1. So, this corresponding, if I give the corresponding oracle, let us say the output is 1, oracle output. So, for this input the correct output should be 1. Now, if you see the original circuit, this equations, whatever the equation I will get corresponding to this circuit, right. So, this circuit, if I put the value of A equal to 1, B equal to 1 and C equal to 0, right, this is what I got 0 1 1, sorry. If I give 0 1 1, A equal to 0, B equal to 1, C equal to 1. So, what will happen, this all I will get, so this is 0 1, G1 will be 0, right, B and C, so this will be 1, C and B is 1, so this will be 1, right. So, this way this value will propagate, right, and then finally I will get an equation only in terms of K1, K2 and K3, right. So, this is what I am showing here. So, effectively this was my equation. If I put the value of ABC, so I just put the value of 0 and all, right, in that bench file. So, all ABC I put the values, and effectively I got this equation, right. So, I get basically this, that K1 not of K1 or K2 or K3 equal to 1. What does this effectively mean? If it is 1, this is 0 and this value will be 0, right. So, effectively this combination of key is now eliminated. So, this is another formula, right. This formula I will add to the original formulas, right. This is what I have discussed. So, effective the idea is that I will put this value to my equations. Here I am showing in terms of bench, but effectively I will I mean effectively I will do that. So, I take the bench file, I will put this value, I will do the propagations, I will get a formula which is in terms of K1, K2, K3. This basically adds some restrictions on the value of keys which will not be true, which will not satisfy the miter circuit anymore, right, which will be removed. Your search space is basically removed. Some of the keys from the search space are removed. So, for this example, this is the equation I will get, which is effectively saying that this value cannot happen of this keys. So, then what I will do, I will basically add this equation to the original formulation of the DIP, right. So, I already have CNF corresponding to this, which has 56 clauses, and now this is another clause which is basically have one clause. So, I will add this clause to this. Now, my formula have 57 clauses, 56 earlier, this is one clause, and this I will do for both copies, right. Effectively there are two clauses I will add, one for the copy of the K1 and another copy for KB, right, that I already discussed. So, there will be 58 clauses. Again I will run the SAT solver and I will get another DIP. So, again if I run the crypto mini SAT, it will say yes, you got a DIP and the DIP is 001, right. So, for this output is 0. Again I put all this value of ABC in these equations, I will get this equation, right. So, this equation is saying that not K1 or not K2 or K3 should be 0, right, and you already have the equation not K1 or K2 or K3 should be 1, right. So, this is another equation, this is another equation. So, these equations if I combine together, it is effectively say that all keys are eliminated, only K6 which is basically 110 will remain. You can cross check. So, what I will do now, I will add this clause to my initial formulations, and in the first iteration I have added this clause which has 58 clauses. Now, for this I will add 2 more clauses. So, it will become 60 clauses, and I will again call the crypto mini SAT on this 60 clauses and tell me give me an input DIP. This time it will return unset because I have already removed all keys, right. First iteration I remove 1. So, this will remove another basically it will also remove 6. So, all 7 are removed. There are 8 possible values of keys because there are 3 keys, 7 are removed, only 1 left which is 110. And since in my formulation what I want 2 different value of keys K1 and K2, right. So, I want 2 different values of keys. So, in my formulation I want 2 different values of keys, and because I only 1 left, so this particular original formulation cannot be true under the additional constant, right, because I have added 2 different constant now, right, this and this. So, with this it will say ki no, there does not exist any input for which there are 2 values of keys left for which output is different. So, it will return unset, and if I just take the negation of the formula, basically this instead of this O1 not equal to O2, I will just check O1 equal to O2, I will get the key. Okay. So, this is how the SAT attack is been run on this crypto mini SAT, right. I hope you understand this. So, this entire thing I have put into a GitHub, right. So, you can get this link here, you can download, right. So, here so far I have just put a zip, but we will put all the detailed benchmarks, everything will get it here, and you can also clone it and install, and you can run all the benchmarks. Here I have shown only one benchmark, there are maybe 20 benchmarks inside this directory, right. So, I will strongly encourage you to take this benchmark from the SAT attack, run on different crypto mini SAT is one example I have given, but there are many popular SAT solvers, right. Mini SAT is there, Glucose is there, Cadical is there, KeySAT is there, crypto mini SAT I have discussed. These are very popular and well maintained. So, you can take all these logic locking benchmarks from our directory and you can run on those tools, right. One good part is that this these tools is basically if you have a CNF formula in Dymax, it will work seamlessly, right. It does not matter which tool you are running. So, only thing you that for your application probably you have to write a small code that can convert this into this Dymax format, right. Many of the tools actually have some Python interface where you do not need to write the exact formula. If you write in some format in Python, they can automatically also convert, right. So, I will strongly encourage you to explore these tools, and these are very good resource for academic research. Thank you.